Okay, let's look at one video that combines separation and togetherness. All right, so suppose there are like 12 persons. All right, three of them they're Americans, four Chinese people, and five Japanese people. We want to put them on a row. So how many rays are there? But first in part A, the Americans they must be separated. All right, so the three Americans they cannot be sit together. They must be separated. So to do that, we think about the Chinese, Japanese, doesn't matter. We only have Americans and non-Americans. So there are 9 non-Americans. We line up the non-Americans. That would be 9p9. So many ways we can do that. Alright. These are the non-Americans. 4 of them they are Chinese. 5 of them they are Japanese. Alright. So there are 9 persons. Alright. And then how do you put the 3 Americans? Among these 9 non-Americans, we put tickets between them. Alright. So altogether there are 10 tickets. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Alright. These yellow tickets, there are 10 of them. Among these 10 yellow tickets, we give it to the 3 Americans. A1 goes here, A3 goes here, A2 goes here. Alright. So in this way, we guarantee that the 2 Americans, there's always at least 1 non-American in between them. All right. So how many ways you can distribute 10 yellow tickets into 3 Americans? The ways to do that is 10p3. Am I right? You have 10 tickets. You put them into the hands of 3 Americans, so that is 10p3. Now, but this is a huge number, right? Never mind the number. What is important is how do we arrive at this calculation. Alright, never mind the answer. The answer is not important. The numerical answer is not important, right? But this is much more important. 9p9 is the ways we arrange the non-Americans. Once we arrange the non-Americans, we discovered there are 10 tickets in between them and include the top and the bottom. So for these 10 tickets, we give it to the 3 Americans to be put, alright? And in doing so, we guarantee that any two Americans, there will be at least 1 non-American. Separate them, alright? So this is the answer. Separation. And then in part B, togetherness. Now what if on the other hand, never mind the American, now the Japanese must be together, alright? We lift the restriction that the American must be separated, but put in a new restriction that the Japanese must be together. So once again, we need to prepare boxes. We need to prepare 1 box for the Japanese. Alright, J1 to J5 will be all the Japanese in this box. And then we prepare 3 boxes for the Americans. We prepare 4 boxes for the Chinese. Alright, so this is American 1, 2, 3. We have Chinese 1, 2, 3, 4. Alright, so altogether there are now 8 boxes. Alright, so to line up these 8 boxes, we have 8p8 ways to do that for these 8 boxes. Alright, for each of these lineup, we open the Japanese box. We open this Japanese box and discover that there are also 5p5 ways we can line up the Japanese box. Alright, you can also line up internally within the Japanese box. Alright, so the answer is 8p8 times 5p5 is 4.8 million something. Alright, the answer is like this. Alright, so that's how we do separation and togetherness. But now the new thing in this example is, what if we combine them together? What if the Americans must be separated and the Japanese must be together? We have 2 requirements put together. Alright, on one hand, the Americans, they must be separated. On the other hand, the Japanese, they must be together. Alright, so how many ways we can do that? Now, obviously, it is not the addition between the 2 answers. It should be smaller than the previous 2 answers, come to think about that. Right, and I forgot the and, very important. Alright, so the Americans, they must be separated. And at the same time, the Japanese must be together. So how do we combine the 2 approaches to come up with this answer? Right, the Americans, they cannot sit next to each other. On the other hand, the 5 Japanese, they must sit together. Alright, now for that, we always think about togetherness first. Alright, togetherness first. Alright, so now, never mind the Americans, think about the Chinese and the Japanese. We have 5 boxes now. Alright, one box for each of the Chinese and one box for the Japanese. We'll put the American last. Alright, we have the Chinese, and then one box for the Japanese. And first we line them up, right? 5 boxes. So now in that way, we guarantee that the Japanese, they are always together because it is in the same box. Alright, so to do that, we have 5p5 ways to do that. Alright, we have 5p5 ways to do that, to line up these 5 boxes. And then you can open the Japanese box and then you multiply to a further 5p5. Even though both are 5p5, but once again, they came from different origin. The first one in black is these 5 boxes, alright? We line up the 4 boxes of Chinese and the 1 box of Japanese. The other purple 5p5 is the internal lineup of the Japanese box, alright? So that settles the Japanese must be together. So how do you do that? The Americans must be separated. Now here comes the Americans. Within these boxes, there are now 1, 2, 3, 4, 5, 6. Now there's no ticket in between them because we cannot separate the Japanese. Alright. So there are altogether 6 tickets. 6 tickets. Right? Only 6 tickets between the boxes. There is no ticket between the Japanese because we cannot insert any American between the Japanese. Alright. So they cannot be broken down. So there are only 6 tickets. Among these 6 tickets, you give 3 of them to the Americans. To do that, we have 6p3 ways. Now it's quite difficult to understand this question. You may want to rewind the video to think about that. Alright, the separation will be considered last. Alright, we consider the togetherness first and then never mind the Americans, set aside the Americans, put the Chinese and the Japanese first, but the Japanese must be together, so we put them in the box. So that is 5p5, and then we open the Japanese box, another 5p5. Now between them we have 6 blue tickets. We give these blue tickets to the 3 Americans. To do that, we can do it in 6p3 ways. So the answer is just a multiplication between these 3 numbers, and that goes to 1,728,000. Alright, this is the number of ways you can do that. If for the Americans must be separated and the Japanese must be together. Okay, this is quite a difficult example. You may want to rewind the video and watch it again. Or you can think about some other scenarios. Say, what if the Chinese must be separated, the Americans must be, and the Americans must be together, and so on, right? Try different combination and see what is the answer you come up with. You can chat with me. Alright, thank you.